Welcome. We are talking today about the skeletal system and articulations within it for Bio 246 Anatomy and Physiology at Concordia University. And we will start right off the bat with some objectives for this first section here. You should first be able to define what a joint is, to compare the structural and the functional classification of joints, and explain the inverse relationship between mobility and stability within a joint. So joints, they are articulations, a place of contact between bones, bones and cartilage, or bones and teeth. The arthrology is the study of joints. And of course, we're going to classify them by structure and their function. There are three basic structural classes: the fibrous joint, which is where bones are held together by dense connective tissue; a cartilaginous joint, where bones are joined by cartilage; and a synovial joint, where the bones are joined by ligaments with fluid-filled joint cavities separating the bone's surfaces. And then we have three functional classes of joints. They are going to be not necessarily related to a specific structure. The functional classes are synarthroses, which are immobile joints. They can be fibrous or they can be cartilaginous. The amphiarthroses are slightly mobile joints, slightly mobile. They can be fibrous or cartilaginous. And the most mobile, that are referred to as freely mobile, are the diarthroses. They are all synovial joints are diarthroses, and they are the most mobile of the joints. As far as range of motion of joints, motion ranges from no movement to extensive movement, depending on the joint. And then the structure of each joint is going to be determinant for its mobility and its stability. There's an inverse relationship, typically speaking, between mobility and stability. The more mobile something is, the less stable it is. The more stable something is, typically the less mobile it is. You really can't have both. You just can't, by the mere nature of the concepts. For the example, the skull sutures are very immobile, but also they're very stable for good reason with your skull, housing the brain and the spinal cord. As far as the relationship between mobility and stability in joints, take a closer look here at our image here, referring to fibrous joints here, where the primary junction is to hold the two bones together, and look at the sutures here of the skull. Sutures and interosseous membrane are examples there. Cartilaginous joints, and pointing here more to the spine specifically here, where the primary goal is to resist compression and tension stress and act as resilient shock absorbers. That's a primary job of the spine, unquestionably, from a standpoint of at least stress, generally speaking. They're immobile or slightly mobile, certainly mobile. Generally, in this case, certainly a little bit mobile. Obviously, each vertebrae is not going to have tremendous mobility, or you could do amazing things with 20 plus vertebrae, right? With a 7 cervical, 12 thoracic, and typically 5 lumbar. That's essentially a lot of mobility. If each one was very mobile, they're not. 1 to 3 degrees, generally speaking, is a very generalized range of motion as far as actual degree of mobility for each one. There's not a tremendous amount, typically speaking, with the exception of like C1, C2 for the cervical spine, which we'll talk about a little bit, and we've talked about in previous units before. Synovial joints, the primary function is movement, like your shoulder joint. So they're freely mobile. They can move through all three planes. The glenohumeral joint, the knee joint, knee joint, I should say, is not going to be able to move. They'll move through all three planes. The knee joint as well, but very minimally. The glenohumeral joint is the best example of a highly mobile, of the most mobile of the types of synovial joints. Generally speaking, so we're looking at from stability toward mobility, very immobile, like a suture being the most stable, and interosseous membrane still being pretty stable. We have our basically invertible joints, the spine being slightly mobile, right? Slightly mobile, those cartilaginous joints. The knee joint, which is a synovial joint, which is, it's more mobile than the spine, but not as mobile at all as most of the mobile joints, particularly like the glenohumeral joint, which is far and away going to give you the most mobility from a general standpoint. But it's also because it's composed of multiple bones and multiple basically structures within there, not just one simple basic hinge type joint like a elbow, as an example. I will talk more about that. But you give mobility when you have stability, and you give stability when you have mobility. So you should be able to then define now what's the relationship between mobility and stability in a joint, and are all fibrous joints also synarthroses, and explain why or why not. And we're going to go ahead into section 2 here, talking about fibrous joints. You should be able to explain the location and characteristics of the Gomphoses, or the Gomphoses, and basically describe the location and function of the sutures, and list the location of the Syndesmoses, and describe their function. The characteristics of fibrous joints: they're connected by dense, regular connective tissue. They have no joint cavity. There's no space between the two different structures, two or more different structures. They're immobile or only slightly mobile. And the three most common types of these fibrous joints are Gomphoses, Sutures, and Syndesmoses. A Gomphoses is basically like a peg in a socket, like your teeth. For specifically your teeth, a great example. The periodontal membranes hold the tooth to the bony jaw. They are synarthrosis. It's a synarthrosis from the standpoint of joints. Okay, but that said, and we're talking about, in this case, articulations of teeth with the sockets of the mandible and the maxillae. The tooth held in place by fibrous periodontal membranes here. It functions as synarthroses. Sutures. They're found in the skull bones. They're very short fibers. They're interlocking, have irregular edges, right? They increase strength and decrease the risk of fracture. They function as synarthroses again. They allow growth in childhood, and they become ossified syndesmoses in older adults. And lastly, our syndesmoses. They are bound by an interosseous membrane. You see this not just here at the radius and the ulna, but also at the tibia and the fibula as well. And they function as amphiarthroses, where they provide a pivot for two long bones. You don't get nearly as much mobility from the tibia and fibula as you do from the radial ulnar joint because of its connection there at from the composition of the way the radius and the ulna meet at that humerus. And that's why you can actually get some added motion, let alone its connection there at the wrist. So what are Gomphoses? Where are they located? And what type of movement do they allow? What's the composition of a suture? And where in the body is it found? And what type of movement is allowed at a syndesmosis? And we'll come back and discuss section 3 shortly.